We'll be encountering a lot of quantities that are expressed in units of energy, but there are lots of different units of energy that are available to us, and one of the ones that we'll run across quite a bit actually arises from spectroscopy, and in particular it arises from infrared spectroscopy. Now, if you've done anything with infrared spectroscopy up to this point in your curriculum, you know that many times the absorptions that occur in vibrations are expressed in units of inverse centimeters. Where does this come from, and why would it be related to energy? Well, in truth, what's happening when we measure a spectrum is we're measuring a change in energy that's equivalent to the energy of a photon. Well, the energy of a photon is just Planck's constant times its frequency. But we can also write its frequency in terms of c divided by lambda, where lambda is the wavelength, or another way of writing this is hc over lambda. So the lambda here is the thing that has units of length, and it's in the denominator. So in fact, this units of inverse centimeters is related to the ratio of 1 over the wavelength. So how can we actually go about converting this now to something that might be, a more conventional metric system type unit of energy? Well, we'll need both Planck's constant and the speed of light. So I'll remind you that Planck's constant is 6.626 times 10 to the minus 34, and it's in units of joules times seconds. The speed of light is 2.9979. And now, instead of writing it in terms of meters per second, I'm going to write it in terms of centimeters per second. So it's 10 to the 10th centimeters per second. The reason I'm using centimeters is so that I can cancel this unit of inverse centimeters here. And what we're going to be interested is how do we express this amount of energy in units of inverse centimeters in terms of joules per mole. All right, so how we would go about doing this is we would basically take our combination of constants here, hc over lambda, and write it out like follows. H is 6.626 times 10 to the minus 34 joule seconds. C is 2.9979 times 10 to the 10th centimeters per second. And then we'll ultimately multiply this by 1 over lambda, but 1 over lambda is just this number that we've given up here. So 1,000 centimeters inverse. All right, when we multiply all this out, we'll end up with a number that looks like this, 1.986 times 10 to the minus 20. And what are the units of this? Well, the centimeters, inverse centimeters here cancels with that. The seconds here cancels with that. So this is in units of joules. Now, you may look at this and say, well, that's not a very convenient sort of amount of energy here. This is equivalent to 1,000 wave numbers. But remember that this is the energy of a single molecule. All right, so we're typically not dealing with single molecules when we're in the lab. We're dealing with moles of molecules. So one way to scale this up to a more meaningful number is to multiply this by Avogadro's number. So we need to multiply by 6.022 times 10 to the 23rd. And this number is in units of particles per mole, or sometimes written simply moles to the minus 1. So when we multiply these two together, 1.986 times 10 to the minus 20 joules times 6.022 times 10 to the 23rd per mole, what do we get? Well, these two numbers are going to give us about 2 times 6, so about 12. So I'm going to get another factor of 10 in here, and the result I'll end up with is 1.196 times 10 to the 4th joules per mole. All right, so we get actually quite a large number out of this, and sometimes it's more convenient to write this in terms of kilojoules per mole. Remember that 1,000 joules is equal to a kilojoule, so this would be equal to 11.96 kilojoules per mole. And so sometimes this is the more convenient conversion factor to use. So if you want to go from 1,000 wave numbers to kilojoules per mole, this would be your factor. So I hope this has helped you learn how to make these energy conversions. We're going to be using wave numbers a lot, so presumably you'll get used to thinking in terms of wave numbers instead of kilojoules.